I'd love to get a sense of the most recent paper you did, what it's about, and then sort of what the real world use of it is.
So our recent paper is on intrinsic decomposition. When we take a picture, what we see is a combination of all the geometry interacting with the light, as well as the materials and their specific properties. Some materials are brighter, some of them are darker, some of them are shiny, some of them are not. And all of these affect the final photograph dramatically. As people, we are able to get what is going on, where the light is coming from. But if we would like to edit this light, we have to somehow separate what the light is doing from what the materials are in the scene. You are seeing this part to be black, and then my skin is brighter. This is not from the light, but from the surface colors, right? Making the computer understand what part of the darkness or brightness is coming from light and what part is actually coming from the surface material is a challenge that we have been after for around 3 decades. Our recent Transactions on Graphics paper is actually the first one to bring in this understanding to the AI world for any photograph that you can think of. The second paper is about how do we start changing the light in a physically meaningful way using this intrinsic decomposition method we developed. That is more specifically about compositing. We are in a green screen environment. It is easy to explain what compositing is because so many of the movie productions do it all the time. They shoot everything in front of a green screen, get rid of the green screen and put the subject in front of a brand new background. That is called compositing. For photographs, for videos, we do this all the time. But when creatives are doing these and creating the new scenes out of the cleaned out background, what they have to make sure is the illumination of the foreground is matching well with the background so that the new object you put in the scene do not look out of place. That requires usually making sure that you put the light sources in the right places, or sometimes in more professional movie production setups, there are huge LED screens that are actually simulating the background's lighting environment, which is all very expensive. And you cannot just do it if you are a person playing with Photoshop, trying to put yourself in front of the Pyramid of Giza, for example. What our follow-up work does is exactly that. Now that we understand how the light is interacting with the surfaces and so forth, how can we first figure out where the light is coming from in the background so that we can make the foreground appear as if it is in the same environment as the background. Again, this has been done for very specific cases, for control scenarios, for expensive capture setups. However, what both of our work really bring forward and make possible is to do all this using any photograph that you may already have laying around. Okay. Your parents need to understand this, right? Let me think about it. So